Hi everyone, welcome to this video, and in this video we're going to solve now the roots of the polynomial function. So in solving roots of this polynomial function, the concept there is what we call the zero product property, and we want to get the roots or the zeros. So makes sense that f of x be equal to 0, so therefore we have now 0 is equal to x minus 3. Now it is just the same with x minus 3 is equal to 0, and then solving that using addition property of equality. So we got now x is equal to 3. Therefore, the root is now 3. So that's quite easy when it comes to the linear. Now let's go in some cases like this one. Okay, let me have it. Let me just make it a little bit bigger. Find the zeros of p of x equal to 2x times x plus 3. Now remember that p of x is equal to 0. So therefore, on a zero product property, you can make each group or each factor could be equated to 0 because it's zero product property. So we have now 2x equal to 0. Therefore, divide both hand side by 2. So x will be equal to 0. Another, we have now x plus 3 is equal to 0. So you deduct both sides by negative 3. So therefore, x is equal to negative 3. Now when you ask in a set, x could be 0 and negative 3 as its zeros or roots. So this is now the final answer. Now another example about if this is now the case. Remember that p of x be equal to 0. So equating that on a zero product property, we have now 3x plus 9 is equal to 0. Therefore, equating that minus 9 both sides. So we have now 3x is equal to negative 9. Dividing both hand side by 3, x would be equal to negative 3 as your first root, or 0. Now next would be 2x minus 8 is equal to 0. So you add 8 both sides. So 2x be equal to 8. Then divide both hand side by 2. X would be equal to 4. Now, when you write now, the zeros are x will be equal to negative 3 and 4. Now, let's have another challenge here. There is some multiplicity. When you say multiplicity, there's an exponent on every factor. So it means that there are twice of x plus 6 and there are thrice of x plus 12. However, there's no difference when it comes to the method because we always remember that h of x would be equal to 0. So therefore, on the zero product property, we have now x plus 6 is equal to 0. And then x, could be in process, minus 6 both sides. X would be equal to negative 6. And then the other one would be x plus 12 is equal to 0. Minus 12 minus 12. Now, it will be equal to x equal to negative 12. Now, when you write now the answer, it's just the same. It would be x would be equal to 6 and 12. However, you put now a note with that 6 with, no, that's negative 6 rather and negative 12 with multiplicity of 2 and negative 12 with multiplicity. This is multiplicity of 2 and multiplicity of 3. So you would see there what is the multiplicity. Now, let's have this one. I think this is quite easy because this was your lesson when you were grade 8 and grade 9 or in your middle school. So remember that y is equal to 0. So 0 is equal to x squared minus 3x plus 2. Now, the thing that you can do with this one is the factoring. So as you can say that using now the sum and product, because it makes sense that the leading coefficient is 1, it's much easier for us to look at. Think of a factor of 2, that the sum is negative 3. So as you can see, you can have now a 2 parentheses. You put x and x will be equal to 0, just changing the position. Factor of 2 that the sum is negative 3. So I could say that it's negative 2, negative 1. Check that. So negative 2 plus negative 1, that's negative 3. I think that would be correct. And then negative 2 times negative 1, that would be 2. So that would be correct. So that's how you go with sum and product, and then you can now do your zero product property. X minus 2 is equal to 0. So plus 2 plus 2. Therefore, you have now x is equal to 2. And then the other one would be x minus 1 is equal to 0 plus 1 plus 1. Then you have now x is equal to 1. Therefore, the zeros or the roots would be 2 and 1. Okay, let's have a little bit challenging here. Now, whenever you have this one, this is some kind of on the fourth degree, right? So let's look at now the possible, we have what we call the rational root theorem. So the rational root theorem is that we could look at now, make sure that the function is arranged from highest to lowest degree. As you can see, this is fourth, third, second, 1, and then 0. It's good, right? Now, you can now look now, this is now your P as the constant and Q is the leading coefficient. Leading coefficient. And then this is now P as your constant. Right? So, we can now work that out, P divided by Q. Now, your P is negative 4 and Q is 1. So, simplifying that, you have now negative 4. Now, if you have now negative 4, let's look at now the factors of negative 4. Now, in a set, we could now use the plus minus because it's negative. Even though it's just positive, you could go on plus minus. So, as you can see, we have now plus minus 1. Always remember, every number has a factor of 1. And then plus minus 1 would be 2. And then plus minus, that would be 4. Now, in a more detailed one, that would be 1, negative 1, 2, negative 2, then 4, negative 4. Now, as you can see, we could use now synthetic division here. Much easier to look at now. If we could divide this one, remember, if the remainder would be 0, that would be equal, that would be a factor, and that's a good one. If that is a factor, so it means it's a 0. Remember, if you have now 1, you can try now 1. So getting now all the numerical coefficient as synthetic divisor is 1. You have now 1, negative 4. Let me just put it here. 3, and then 4, and then negative 4. Now let's look at if we could get that. 1 times 1, that is 1, be negative 3. Negative 3, that would be negative 3. And this is 0, 0, and then 0, and then 4. That's good. So this is 4, and then this is 0. Now, if we could write this one, so it is now a factor, so therefore, 1 is good. So we could write now that the quotient would be x, because it's in the fourth degree, right? Am I right? Yeah, it's in the fourth degree, so we have now x cubed minus 3x squared, 0, that would be plus. So you have now, should be 0x, then plus 4. Now, this is now another, so we could say that this could be multiplied to, remember we have 1, so if x equal to 1, therefore it would be x minus 1. So this is now x minus 1. So we can now look now on the third degree. So once again, you have now 1 and 4. So it's still here, under here. But let's look at now negative 1 using this one. Okay, let's go. This is the first synthetic division. Now let's go on the second synthetic division. However, what we're going to use now is the x cubed minus 3x squared plus 4. However, remember, there is a missing term, so we could use this one. As you can see, this one. So we have now 1, minus 3, 0, and 4. Then I'm going to use now negative 1 as the second one here. Look at that, this one. So that is negative 1, so 1 times negative 1, that will be negative 1. So that will be negative 4. Negative 4, that will be 4. Bring down is 4. It's negative 4, so this would be 0. Once again, it's correct, and then there's no remainder. So we could have it here. So we can write now the factor form of the function. We have now x squared minus 4x plus 4, and then we have the x minus 1 Remember, we divide this one by x plus 1. Where does the x plus 1? Because we have now x is equal to negative 1. It turns out to be x plus 1. So, as you can see, this is now the two factors. So, we're leading this to this one. Now, if we have that, remember that this is a PST. PST stands for perfect square trinomial. X squared minus 4x plus 4. We can factor it out. This is just equal with x minus 2. Then x minus 2. Or you could write that as square of x minus 2. So therefore, we can now see now the factors. So the factors are x minus square of x minus 2, then x minus 1, and then x plus 1. Therefore, the roots are so we have 2, 1, and negative 1. 2, 1, and negative 1. Then the 2 has a multiplicity of 2, if you were asked. So, however, the answer is this one. The roots are 2, 1, and negative 1. I hope you learned something with this video. Thank you for watching. Have a great day, guys.